Complete the table of values for y is x minus 3 all squared. So if we start with x equals 0, y is equal to 0 minus 3 all squared, which is negative 3 squared, which is 9. When x is 1, it's going to be 1 take away 3 squared, which is negative 2 squared, which is 4. When x is 2, it's going to be 2 take away 3 squared, which is negative 1 squared, which is 1. When x is 3, we've got 3 minus 3 squared, which is 0 squared, which is 0. And then when we move across to x is 4, that's 4 minus 3 squared, which is 1 squared, which is 1. And then if we look at the symmetry down here, we should see that's 4 and that's 9. So we want to plot the points. So we've got 0, 9. We have got 1, 4. We've got 2, 1. 3, 0. 4, 1. 5, 4. 6, 9. And then we just want to put a nice smooth curve through this and try to make it look symmetrical. If you look at the shapes of some quadratics, it will help you draw these. And so that is y equals x minus 3 all squared. Note that it's just a translation of y equals x squared 3 units to the right. What's the equation of the line of symmetry? Well, we can see the line of symmetry comes straight down here, and you should recognize that as being x equals 3. Note we didn't need to use the x is equal to negative b over 2a formula, but we could have done. So if we expand out the x minus 3 all squared, you get x squared minus 6x plus 9. And if you compare that with the general quadratic, ax squared plus bx plus c, you should see that a is equal to 1 and b is equal to negative 6. If you do negative 6, you get positive 6. 2 times 1 is 2, and that's 3. So x equals 3 is the line of symmetry. What are the coordinates of the vertex of the curve? Well, that's just here, and we can just see that that is 3, 0. You can also spot that from the table of values. Is the vertex a maximum or a minimum turning point? Well, this vertex is the lowest point on the curve, so that is a minimum. Quadratics are always either what's known as concave up, and note that they're U-shaped, so that's concave up. Often when teaching we refer to this as happy, or they're concave down, and when we're teaching we often refer to that as sad. So if we have a happy curve, it has a minimum turning point, and a sad curve has a maximum.